Hello students, today we're going to talk about mixture problems, which in your book is Chapter 2, Section 6. So the purpose of this lesson is that at the end of this lesson, you should be able to solve mixture problems. Now I've created this table that you see in front of you, and it should look very similar because it's similar to the table that we used for solving distance, rate, time problems. We still have the same label. We still have the same other extra 3 columns, but we label these A, B, and combine. A represents the first chemical or mixture, B represents the second, and C is combine. Over here we have percent or price. Now this refers to the percentage of the chemical solution or the price of, say, the mixture. We give it these subnotations, for example, percent sub 1, percent sub 2, percent sub combine. And these are used to notify you as to the first, the second, or the combine. It's just the way we notate which is which. Then we have the volume, so volume 1, volume 2, and in the combine you'll see volume 1, volume sub V sub 1, plus or minus V sub 2, where the plus or minus really represents if we're combining or if we're adding 2 chemicals together, or subtraction if we're evaporating or taking away. In the scope of what we're going to be doing in algebra class, you'll just mainly be using the addition sign. What's great about this table is that we've added this extra column, or extra row. What this row does is it helps us to organize our data just by multiplying downwards. So percent sub 1 times V sub 1 is just down here and being multiplied together. Percent sub 2 times V sub 2, V sub 2, yes, is multiplied down here, and same thing goes for combine. And you'll notice that in between A and B there's a plus or minus sign. It's the same reasons for why we have the plus or minus here in combine, and we have the equal sign. So we're adding these two mixture slash volumes up, and that's going to be equal to the combine. So let's take a look at an example. A chemist has a 30% acid solution and a 70% acid solution. How many liters of each solution does the chemist need to make 500 liters of a 56% acid solution? So we're going to fill out this table, and we're going to call column A the 30% solution. Column B, we're going to call the 70% solution. Now here's a part that people commonly make mistakes on. The combined is not going to be 30% plus 70%, but rather the percent acid solution that we want when it's combined, which in this case is 56%. Then if we look at the volume of the 30% solution, we really don't know. So of course when we don't know, we're going to define a variable, say x. Now we do know that we have 500 liters total. So we know that when we combine it, it's 500 liters. Now, to come up with this portion for the B, well, it's going to be 500 total minus however much there is for x. Therefore, we have 500 minus x. So to come up with the equation portion of our row, we're going to multiply 30% times x. But keep in mind, we cannot leave this 30% as a percent. We actually have to convert it to a decimal. And we do that by dividing by 100 or moving the decimal place 2 places to the left. So 30% times x is 3/10 x. 70% times the quantity 500 minus x turns out like this. And 56% times 500 becomes 56 hundredths times 500. So now what we're going to do is we're going to simplify our equation really quick. So what we're going to do is we're going to multiply, or we're going to bring down our 3/10 x. I'm going to change the color for us really quick. Plus 350, because 7/10 times 500 is 350, minus 7/10 x equal to 280. Then we're going to combine like terms, so 3/10 x minus 7/10 x becomes negative 4/10 x plus 350 equals 280. Then we're going to subtract 350 to both sides, and we're going to be left with negative 4/10 x equal to negative 70. So then what we're going to do is we're going to divide by 4/10 to both sides. We're going to divide by negative 4/10 to both sides. And that should give us 175 liters of the 30% solution. So this is for the 30% solution. Then we need to figure it out how much we have for the 70% solution, which in this case would be equal to 500 minus x, so that should be 325 liters. Let's try another problem. It says black tea costs $4.99 an ounce and jasmine tea costs $12.99 an ounce. How many ounces of each should you use to make a 16-ounce mixture that costs $6.99 an ounce? So we'll start off with black tea. That's $4.99. Jasmine, $12.99, and combined that should be $6.99. So the volume for the $4.99, surprise, surprise, we don't know. So we're going to give it a variable, which in this case is x. We do know how much we have for the total mixture, which should be 16. So rightfully so, this should be 16 minus x. Then following the same procedure as before, we're going to multiply down, giving us 499x, 1299 times the quantity 16 minus x, and 699 times 16. So we're going to do some simplifying again, and we're going to be left with 499x plus 1299 times 16, and that's going to give us 207.84 minus 1299x equals 699 times 16, which is 111.84. Again, we are going to combine like terms. So we have 499 minus 1299. That gives us negative 8x plus 207.84 equals 111.84. Then we're going to subtract 207.84 to both sides to isolate the variable. And we are left with negative 96, I'm sorry. Then we're going to divide by negative 8 to both sides, leaving us x equals 12. Now this tells us that we need 12 ounces of the 499 or of the black tea, and we need 4 ounces of the jasmine tea. So notice how we're getting so much more of the cheaper tea than the more expensive tea. Now it's your turn. Read this problem, and once you're done, post your answers to Edmodo. Remember, if you're the first one to post, you'll start us off. Everyone else, you'll just reply to the initial post. That's it for now. I'll see you next time.